Hi, welcome back. The problem today is about the equation that contain three variables. They are a, b, c, and they are real positive numbers. Give try before see my solution. Now, let's get started. Okay, from the problem we have a, b, c greater than 0 and a, b, c are real numbers. On the left hand side, that is a squared plus b squared plus c squared plus 2abc plus 1. And on the right hand side, that is 2ab plus bc plus ca. Okay, so for the first look, you can easily to guess the root of this equation. This is 1. It means a equal to b equal to c equal to 1. And we know the root of the equation, but how can we show that? So the method is you have the expression like a minus 1, b minus 1, c minus 1, y is 1. Because 1 is the root, you already guess that. Then from these expressions, you can recognize that there are always two products of these expressions would be greater or equal than 0 always. For example, you see, imagine if a minus 1 is the negative numbers and b minus 1 is the negative numbers and c minus 1 is the negative numbers. On this negative, it means smaller than 0, but the product of them will be greater than 0. And another case like if a minus 1 greater than 0, b minus 1 smaller than 0, of course c minus 1 can be greater or smaller than 0, but when you multiply with b minus 1 or a minus 1, this means we always found one product of two these expressions have greater or equal than 0. In this case, we assume that this is a minus 1 and b minus 1, and their products would be greater or equal than 0. From this, you can have a, b plus 1 minus a minus b greater or equal than 0. So transfer it, then you have a plus 1 greater than a plus b. Okay, so the next step is you multiply two sides of inequality by c, and c is positive number, so it will not change. The greater sign here. Then you will have a, b, c plus c greater or equal than ca plus bc. And the next is you multiply by 2. Then 2abc plus 2c greater than 2ca plus bc. Okay, you can see on the right hand side that is missing 2ab. So we just plus 2ab on both sides, you would have 2abc plus 2c plus 2ab. And now on the right hand side of the inequality will be equal to the right hand side of the equation. And this is the expression in the left hand side of the equation. And you have c square plus 1 plus minus 2c will be equal to c minus 1 square, and this always greater or equal than 0. Similarly, we have a square plus b square minus 2ab equal to a minus b square greater or equal than 0. This means c square plus 1 greater or equal than 2c, and a square plus b square greater or equal than ab. This is 1 and this is 2. From inequality 1 and inequality 2, you would combine with this one. Then you will have a square plus b square plus c square plus 1 plus 2abc greater or equal than 2abc plus 2ab plus 2c and greater or equal than 2ab plus bc plus ca. So from this chain of inequality, you would see this is the left hand side of the equation, and this is the right hand side of the equation. Then this the left hand side always greater or equal than the right hand side, and the equation happens when a equal to b equal to c and equal to 1. So the final answer of this problem is a equal to b equal to c equal to 1. That's all. Thanks for watching. See you later. Bye.